talking about the Pythagorean Theorem today. So it was invented by a person named Pythagoras in ancient Greek. So the formula basically states that a squared plus b squared equals c squared. A and b are both the legs of the right angle triangle, which a right angle triangle is a triangle which has an angle of 90 degrees. So with this, we were able to solve many geometrical mathematical problems because we can just subtract and then square to get the missing side. And now we also have another formula. We have side 1 equals m squared minus n squared, side 2 equals 2mn, and side 3, which is the hypotenuse, equals to m squared plus n squared. With this is proven by the Pythagorean theorem. If we substitute m squared minus n squared as a, 2mn as b, and m squared plus n squared as c, because m squared plus n squared is the longer side of these two, of all the three sides, because obviously it's the biggest. So yeah, if we substitute, we have this equal to m fourth minus 2m squared plus n squared plus n fourth plus 4m squared. We get m fourth plus 2m squared n squared plus n fourth. Now this is equivalent to the square of this. Thus it is proven that this is true. Now a Pythagorean triple is three positive whole numbers which can fit in this equation. But with this formula, we can achieve an infinite number of possibilities with Pythagorean triples. However, two numbers cannot be part. They are 1 and 2. The proof is because 2 squared is 4, and no two positive numbers, no difference of the square of two positive numbers can be 4. This can be seen here. 2 squared minus 1 squared is 4 minus 1 equals 3. So that's the smallest possible difference. But so 1 obviously can't be anymore. So now 3 squared minus 2 squared, that's equal to 9 minus 4. 9 minus 4 equals 5. And then among this 3 and 5, 4 is not present. That means 4 can no longer be present because the values will continue increasing. Thus, it is proven.
Now, we'll show you a proof of the Pythagorean theorem. So, this is proof number 9. We got this from a website that has 99 approaches on the Pythagorean theorem. So, we have 4 triangles here and 1 square. So, let's make these triangles all equal right angle triangles. So, the base would be B, and let's name the height A. So, now I'll place the triangles inside the box. As you can see, we now have 2 boxes inside. So B is equal to 4 centimeters and A is equal to 10 centimeters. This is the same diagram. So B, B, A, and A. So B multiplied by B would be equal to the area of the first of the smaller box, and A multiplied by A would be the area of the bigger box. Let's substitute B with 4. So 4 multiplied by 4 is equal to 16 centimeters squared. Then let's substitute A with 10. So 10 multiplied by 10 equals 100 centimeters squared. Now we'll find the area of the whole figure. So since we know that this is A and this is B, we just multiply A and B to get the area of the 2 triangles combined. So A, which is 10, multiplied by B, which is 4, is equal to 40. So we know that it is 40 centimeters squared. Now, to find the area of the whole figure, we add all the areas. So, and considering that these combined triangles are 2 sets, so 16 plus 100 plus 80. So the area of the whole figure is equal to 196 centimeter squared. Now that we know the whole area of the first figure, let's see if it's still the same with this rearranged figure. So we know that this is A, this is B, and let's name this side C. So to get the area of the whole figure, we need to find the area of this square first. So C squared plus all the areas of the four triangles, so plus 4 AB over 2. We get the area of the whole figure. We'll now subtract the area 196 centimeters squared to the area of the triangles here, which is 80 centimeters squared. And we'll get 116 centimeters squared, which is equal to what we'll get if we add a squared and b squared of the other figure. Since we know that a squared is equal to 100, and if we add b squared, which is 16, we get 116 centimeter squared. We are certain now that a squared plus b squared equals c squared.
Now, to understand the Pythagorean Theorem better, we'll have a word problem. Bob lives in point A on the circle plot and area, directly due north on the circle against Xavier School at point C. His friend, Frenchie, from China, lives at point B on the circle, and he is 720 meters away from Bob's house at point A. The 3 points on the circle form a right-angled triangle at point B. The distance between Frenchie's house and Xavier, or point B to point C, is 300 meters. Bob leaves his house 1 hour earlier than Frenchie and travels at a speed of 480 meters per hour. They both arrive at the same time. How much does Bob have to travel in meters? Also, how fast is Frenchie traveling? To answer this, we'll apply the Pythagorean formula. This diagram shows the different points where the places are situated in the circle and how they form the right triangle. Using the formula, let's say that A is 720 and B is 300. We now square them both and add them. We get 608,400. We now find for its square root, which is 780. Now we know the answer, that Bob has to travel 780 meters. To answer the second question, we need to find the number of hours that Bob took. We now subtract the answer to 1 hour. 300 meters will be divided by 0.625 hours. We then get the answer that Frenchie travels at 480 meters per hour.